Hello everyone. In this video I am going to demonstrate implementation of amplitude modulation in a power inverter. So as you can see, this is the power inverter I am having. So this is how the inverter looks like. So this is the power transformer of the inverter, and this is the switching device. This is the IGBT switching device. Below you can see there is the IGBT. You can see here is the IGBT below. So this IGBT is driving this transformer, and in order to drive this IGBT I am using the concept of modulation. So what I am doing, I am having a 555 timer IC as an oscillator. So this is my oscillator. My oscillator is supposed to oscillate at a frequency of 48 kHz, and I am mixing a square wave of 50 Hz with this oscillator at the pin number 4 at the reset pin. You can see this is the transistor. The base of this transistor I am feeding 50 Hz signal, and as a result the 48 kHz signal is a pulsed 50 Hz signal. Let me show you on the diagram. So as you can see on this diagram, this is the 48 kHz frequency. My oscillator is supposed to oscillate at a frequency of 48 kHz. However, when I am mixing a modulating signal of 50 Hz, this is the modulating signal of 50 Hz, I am going to get this output waveform. The frequency will be divided by 2 in this waveform. As you can see here, wherever is the square wave, at that point only I am having 48 kHz encapsulated with the square wave. So this is the final modulated signal. So this modulated signal is fed to the IGBT as well as it is fed to the transformer. So let us see on the diagram. So as you can see on the diagram, this is the 555 oscillator, and I am using this transistor. This transistor I am feeding 50 Hz to the gate of this transistor. The 50 Hz signal is the modulating signal, and this oscillator is generating the carrier signal. Finally, at the pin number 3 of 555, I am getting the modulated waveform. The modulated waveform is fed to this power device, local power device, and it is driving this small transformer, isolation transformer. The secondary of this isolation transformer is finally driving the power device below. So this is how the switching mechanism of this circuit is designed. So now, as you can see here, whenever I am feeding the input with certain waveform, the output is supposed to be 220 volts AC. The transformer is designed so that the output gets 220 volts AC. So that the output is 220 volts AC. However, we are not going to get 220 volts AC at the output, since the efficiency of this modulated power inverter is very low. That's why we will be getting very low voltage at the output. You can see there is a demodulator. So this is a Schottky rectifier, and this is the capacitor. So this part is used as a demodulator. The secondary of this transformer is a 220 volts winding, and the 220 volts supply is fed to this demodulator circuit. Upon measurement, we are going to see the output voltage is very low. So let us power up the circuit and see the responses. So as you can see here, this is the circuit. I have powered up the circuit. You can see the load lamp is glowing. However, the voltage is only 57 volts AC. The voltage is supposed to be 220 volts AC, but it is only 57 volts AC. And you can see here, this is the output frequency. Frequency is 50 Hz. You can see the frequency is 50 Hz. So as you can see here, the voltage should be 220 volts AC. However, I am getting only 58 volts AC. So the efficiency is very low.